Welcome to this GlobalSpec Quality Test and Measurement online event. Test stations that utilize commercial off-the-shelf instrumentation often have complex setup and test sequences requiring operators to follow detailed instructions. These instructions lead the operator through various instrumentation menus and parameter selections, exposing the process to variation and errors. These issues can be addressed by controlling the COTS equipment with an embedded real-time controller networked to a central PC for process setup and data collection. Now, before introducing our speaker, we'd like to invite you to submit questions at any point during this presentation by using the Submit Question button at the base of this video console. Also, some of the presentations you will see today include detailed information, so we would encourage you to click the Download PPT button so that you can follow along with your own copy of the PowerPoint slides. Rob Putala is a Senior Systems Engineer at Bloomy Controls Incorporated. He is involved with development of test systems for subassemblies and final products for many industries. Rob received a BSEE from Michigan Technology University and an MBA degree from the University of Notre Dame. Rob, welcome to today's event.
Hi, my name is Rob Putala. I'm a Senior Systems Engineer at Bloomy Controls. I have about over 30 years experience, mostly in test, but also quality and some OEM product development. Here at Bloomy, we are systems integrators, turnkey system developers, as well as at NI Training Center. We have three, actually, NI certified training centers. Our founder wrote the book on LabVIEW style. You may have seen it. And we are also an electronic design specialty. What I'm going to talk about today is basically benchtop test equipment. Starting out just to give a historical progression, and then finishing up with the advantages of using a real-time controller to simplify the benchtop test. The timeline I have here, just some images to help display what I'm talking about here. Way back in the 70s and probably even earlier, an engineer would put a piece of test equipment on a bench, write a test procedure, interface it to a unit under test, and that's how testing was performed. And I think it still is in many places today. This went on for quite a long time. It was quite standard till the advent of the PC. And with the PC came along the GPIB bus and other protocols, and that was used to control the benchtop test equipment. Subsequent to that, some of the benchtop test equipment had internal controllers and such. What I'm going to focus on is utilizing an embedded real-time controller for controlling this type of benchtop test equipment, and also discuss the advantages of doing so. When I'm talking about benchtop test equipment, it's mostly a commercial off-the-shelf instrumentation. You have digital multimeters, signal generators, high pots. There's a lot of test equipment out there, and most of it has at least an RS-232. Most of it has GPIB. Now you can get other interfaces as well. And this shows on the timeline what I'm talking about. It's really the methodology is from back in the early days. These were implemented using a written test procedure, and I'm sure we've all written them, where you instruct an operator how to set up the equipment, what to connect, what button to set, what switch to flip, what to observe, how to connect it, and likewise, subsequently, these procedures can get rather, complex and difficult to understand. So people that have gone through it once or twice pretty much understand what they're supposed to do, or they believe they do. What happens is over time is some sections quit working. I have seen this where there's whole sections of procedures just crossed out and nobody can really realize or remember why. It could have been an ECO to the product. It could have been a broken pin on the test equipment. It could have been just a misinterpretation, or maybe they went from this brand of oscilloscope to another brand and now the knobs aren't labeled the same, or something like that. Another interesting note that I've seen on procedures is written in the sideline, in the margins, something like check with Joe or see so-and-so. And in one case, I did see that, and I asked the operator, I go, well, what's this all about? And they says, oh, that person left the company a long time ago. So there it was. So most of the procedures then, or what's really happening is they're performing these tests based on their local knowledge. In came the PC, which certainly helped things. I do want to go back a little bit to the local knowledge. I do recall one instance where I observed an operator setting up a signal generator and an oscilloscope to tune these modules. And the operator proudly said, "I know exactly how to do these. I remember," sets them all up as I watched. And the operator took the tuning wand and set every one of them for a null. And I watched this and thought, that's odd. Setting them all till you get no trace on the scope. Now, I'm not sure how that came about, but that's how the units shipped. And following up as to how this could possibly be used, the next station, next people who use it says, "Oh, these always come in unadjusted." So they were setting up equipment and readjusting them all. The point is, everybody thought they were doing a good job and they were doing their best, but the fact is, they forgot. They simply forgot how it was running. So to get back on track here, PCs came online, and with GPIB, you could now control the test equipment itself, so the setup and all that. And there's a couple problems with it in many instances. For one, the PC does take up a lot of bench space. We've all been out in the production floor, and bench space can be quite a premium. Other things that happen with PCs is they're great for email. During break time, they're good for surfing. Or even for business uses, if they want to look up parts, they'll maybe connect to the company's system. Some of the other things to consider is support costs. That's can be very considerable if you have a lot of PCs. And also, old OSs, Windows, PCs typically last a lot long. How should I say this? The production cycles can last the lifetime of a PC and then some. One of the issues that came about when PCs were first introduced, and I intentionally show a graphic here of a very old PC because this was an incident that actually happened. I was asked to look at a test setup because production was down, and yes, it was for support or a repair parts or something. It was a somewhat old product, but what had happened is the PC wasn't functioning at all, and the root cause of the issue was the CMOS battery had simply expired, and that wasn't all that big of a deal, changing the CMOS battery. But then, in order to get this old PC up and running, I also had to. Maybe many of you remember with the old-time BIOS, you had to tell it the drive type, the number of cylinders, and the number of heads. And then that pretty much got the system running. Then it just took modifications of the batch file so it operated the way the operator remembered it did. The reason I bring this up is it does seem like maybe an odd issue, but the point is PCs advance very, very quickly. Product life cycles can be very, very long. This type of issue, it will manifest itself again. There's just no doubt. PCs wear out, and somebody's going to have to fix them. The other thing is with PCs being used for benchtop test equipment is you're back usually to a written procedure and the crossed out sections and the notes. And now you also potentially have a screen of the software that was being used to run the instrument. That can be rather complex, and if it may be okay now because the engineer that understands it sets it up, programs it. 5 years from now, another engineer may have to look at that, relearn the software to try to figure out what was really going on. Now, these are the kind of things that are going to happen. So to address some of these issues, Bloomy has developed what has been called a headless ATE. It's headless because it has no monitor, no keyboard, or no mouse. There's just some simple buttons and some LEDs. All of the buttons you see on the front panel of the test equipment really are not used at all. The operator has very simple tasks. Now, this headless ATE, this is just a block diagram to show how simple it really is. You have the commercial test equipment being controlled by a real-time controller that simply has a power supply, some LEDs, and some buttons. Now, the controller has an Ethernet port. Many of the controllers have a variety of different communication ports for whatever type of test equipment you need to interface. And I think the LEDs and buttons are pretty self-explanatory. What we use at Bloomy is a single board reel from National Instruments. It is really nice because it not only has a lot of I/O, analog and digital I/O, it also has flash on it. It runs LabVIEW, communicates with the test equipment, communicates with the central PC, and being real time, it does a couple of things. You turn it on, it's on. You don't have to wait for a boot, and it's really not prone to virus attacks. What the architecture of such a system would look like is just one central PC to a switch to many of the headless ATE systems. I just say many because you could put quite a few on there. I think the reasonable number is probably would be limited by the complexity of the test being put into place and the staff available to put these things in. In one installation, a customer did reduce their PC count from 17 to 2, and they really didn't need 2. They just wanted to have a hot spare. They wanted a hot system on. If one went down, the other one was right there to take over. And that was simply because they were very high volume production and downtime was very, very costly. So in any particular case, you might just get away with one. The central PC, controls the testing, and it also collects the data. As a brief software structure, what the supervisor or what the PC is doing is it's pushing a configuration down to the commercial test equipment. If you want to set up a DMM for a sequence of events or any particular range settings, it can do that. Many of these commercial off-the-shelf test equipment do have menus and such things that you could to program. And then you could also send a command saying when it is okay to begin test. What you get back from the headless ATE, this controller, is the results and calculated process data. The test might actually be taking a whole array of values, maybe multiple different tests, performing some type of calculation or data manipulation. You're only limited by LabVIEW, which it's not a limitation. You could do quite a bit from it, and just have the results transferred to the central PC. And I think that's it's very, very handy. The central PC also will do SPC calculation, as well as providing status of each of the stations and send any alarms. If station X was experiencing a rather high fallout, you could have an email go out to a manager or an engineer have somebody go and take a look at it and see what's going on. This is a SPC screen. It's available on the central PC. You have an upper control limit, lower control limit, just a run chart. And depending upon the complexity of the test and the software, you could also have Pareto on fallout. And realize this is all real time. This isn't running a lot of production and looking at the data to see, well, what could have done better, what's failing. You would know real time that something is going wrong, or that all is going well, which is just as important. You can get the start time, the stop, the part number that's being run on each particular station. Another screen is the system status screen, where you could overlook all of the remote test stations. Which ones are running, which ones are idle, which ones are, what part number they're set up for. The administrator can go in and simply select another part type if once you have your different parts set up, and reprogram that bench test equipment for another part type, and then send a command that it's ready to test. And so it's very, very handy. You you get things like the total number tested, total passed, failed, your yields, test time, a lot of very good management information. So that's kind of it in a nutshell. The advantages of using headless ATE, is, I think, primarily the reduction in variance. You're not counting on the chance of human error in setting up test equipment incorrectly, or reading the wrong data, or not following the sequence correctly. Now understand, this is really directed at benchtop test type equipment, and I'm certainly not down on using PCs. We use quite a few of them, as we all do. But this is just something to think about if you have a test system where you have a single or maybe two pieces of commercial off-the-shelf test equipment performing some type of a bench test. I think the data collection alone makes this effort worthwhile. And really the payback is in the reduction in process variance. So that's pretty much it. If you would like to learn more about this or speak with us, please contact us through bloomy.com. Thank you very much.
Thanks very much, Rob. We have some questions that have come in from the attendees, so let's get right to them. The first one asks, why is National Instruments single board RIO any better than a PC running Windows?
The real-time OS in a single board RIO is more reliable, dedicated to its purpose, and requires less IT maintenance. It has fewer vulnerabilities, especially with viruses and such, and it does not require a monitor, keyboard, or mouse, so it takes up less space. Also, if you use a real-time controller, you'll see there's no boot time. You turn it on, it just comes right up. There's no searching for files. There's no operator selections to be made. No unintended uses. And additionally, there's available digital I/O and analog I/O, which a test engineer might find very, very useful when building the remote system.
Is it possible to achieve the same result with a Windows PC by designing a very simple GUI with only a few buttons?
It is possible to create an application with a simple GUI, but it's very difficult to really lock down a PC and prevent access from other uses, as we've discussed before. Also, revisions control of the software becomes an issue, or might become an issue. And also, we have logins at the remote system and at the central PC, whereas in the system that I've described, the administrator would set passwords and logins for the engineers and the operators on one system, the central system. Whereas if a PC was at each of these test stations, you'd have to have logins for the test engineers and all the operators at each of the PCs, which could become a little bit, complex and prone to error. Another thing to think about when using a PC is the effect of the operator choices and searching for files and is this set up right? I read a white paper some time back on process setup for manufacturing. And it's kind of a similar situation here. And what the writer of that paper said is he compared process setup to a NASCAR race. He says, have you ever seen a NASCAR car come into the pit and see a mechanic fumbling around for a wrench? And the answer obviously is no. And that's really kind of what this system is doing for test. The unit under test comes up for the operator. It's a very simple controls. She knows, the operator will know what to do. The central PC has already set up everything for whatever unit under test is going to be there. So there's a considerable savings there also.
Okay, next question. Because there isn't a PC, keyboard, or monitor, how does the operator receive instructions?
Primarily via the pass-fail LEDs. Also, some instrumentation will have displays on them. I've used that in the past for various messages. So, the goal is to simplify the test experience. With a simple operator interface, there's less operator training, and that greatly adds to a manager's flexibility. I've noticed that many contract manufacturers in particular an operator will be running a test, one shift, maybe during half the part of the shift, that operator is asked to go do some assembly work. And maybe some hold up in production sends the test function to the second shift. So now you have a different operator yet. Having a PC there might cause some training difficulties. Again, it's just the simplicity of the remote systems is what I'm really talking about here.
If the Ethernet connection between the SB-RIO and the central PC is temporarily lost, does the test operation stop?
No. Again, the SB-RIO has an FPGA, and all that test data is safe. When the Ethernet connection is reestablished, the central PC will communicate with the remote stations and upload the data to, timestamp data into the database. On one setup, we had estimated we'd have over 24 hours on each station of data. And obviously, depending upon which SB-RIO is put in there and how much memory, that could be even much larger. And it also, of course, depends on the amount of data taken at each step, which is sort of key in using an SB-RIO running a LabVIEW, because it's only processed data that gets stored. Again, I had spoken during the discussion that if this equipment is used to, say, take a large array of data and perform calculations on it, the end result is what's being stored. The answers you're after, pass, fail, and it's time-stamped. And yes, that is all safe in the flash memory until the Ethernet connection is reestablished and it is transferred.
Okay, here's another question. If the internet connection between the SB-RIO and the central PC is temporarily lost, is there a loss of test data?
No, not at all. The test data, the testing continues. The test data is all stored, and it's all time-stamped correctly. It will be entered, transferred in and entered into the database just as if it happened real time.
Okay, next up. Many IT departments are reluctant to allow test equipment on the company network. Has this been an issue?
Actually, no, it has not. There is one central PC that does go onto the company network, and this is very handy for issuing alerts, email alerts, or any kind of alarms, or however, whatever structure you want to have, and whoever you want to have notified. But having the SB-RIOs, which are real-time controllers, on a subnet has not been an issue, because the IT department really doesn't seem to care much about that. Yeah, I guess you would have to check, but I can't see where having an embedded controller on a subnet would be an issue for IT.
What functions are typical for a person logged in as administrator, engineer, or an operator?
Well, an administrator can add or remove operators or engineers, work with a database, assign notification levels, and other administrative tasks, just like on any PC. The engineer will be developing the tests, review the test data, configure the remote test stations as needed, and the operator can log in and run tests. And actually, the operator login occurs at the central PC. In other words, that central PC, the admin there or engineer would just set it up and say, operator 123, you're on system 4. And they're logged in on that system.
Will the PC that downloads the test sequence and retrieves data generate alerts based on failure rates?
Yes, alerts can be generated by many methods, including not only failure rates, SPC levels, which operator is logged onto which system, whatever the admin really sets it up for. So I guess that's, and the alerts can be emails. They can, actually I was thinking if we wanted to have an alert using some of the extra digital I/O lines on a remote system, you could actually have the alerts to the operator itself saying that something is wrong, telling her to stop, or her to stop testing, or whichever.
How many remote test systems can be controlled by one PC?
Technically, the limit on how many remote systems is very, very high. I think it's going to be really up to the complexity of the remote test station and the available staff. Hardware-wise and software-wise, there really isn't a restriction, but I think in practicality, it would be dependent upon what's put in place.
What is the advantage of using an SB Rio for the control as opposed to using programming features of the COTS equipment?
Programming on the COTS equipment may directly involve multiple menus, typically complex keypad operations. Since the equipment is usually 1U, 2U high, there'll be a keypad with menu after menu after menu, and then we're right back to the setup issues and such. The other thing is if you have two pieces of equipment working together, you'd have two programs to set up, adding to the complexity. And also if you have multiple stations with different types of equipment, it gets even more complex. Doing it all through a single board Rio as an embedded controller and having have the engineers set up the tests correctly to where an administrator or an engineer can simply set up a test station based on part number. When they're running a certain part number on a test station, from the central PC, that's the part I want to run. The engineer's instructions are downloaded to the equipment, and everything gets set up. And again, the goal of this is simplicity. Very simple operation. And utilizing the COTS equipment with the menus and the push buttons and all this stuff doesn't really work towards the goal of simplicity. We're going back to adding complicated operations.
Okay, we've got time for one more, Rob. Very simply, what is the cost of this system?
It depends on the instruments, test programs, etc. Please contact bloomy.com and we can discuss that.
Okay, Rob, those are all the questions we have for now. We'd certainly like to thank you for sharing your time and insights with us today. Before moving on to explore the exhibit hall of this event, please take a moment to click the Take Survey button and let Rob know how he did today. Your feedback helps us improve the quality of our GlobalSpec events, making them an even better investment of your time. In between sessions, head to the exhibit hall where you'll find manufacturer product reps, engineers, technical specialists, and other professionals waiting to answer your questions. Remember, you can see any of today's presentations during our on-demand period, but exhibitor representatives are only here on the day of the live event, so spend time with them while you can. Please experience our latest innovation, the Knowledge Exchange, offering product demonstrations and our hot topic audio briefs. The Knowledge Exchange is also home to our event price center, so make it a point to visit. Share your thought leadership point of view by speaking at one of our events. You can find the speaker submittal form at our event help desk in the exhibit hall. Well, we'd certainly like to thank you for choosing to spend your day with us, and we'll see you back here in the conference center a little later on.